Welcome to EDU World Space.
We are told we have a walkway here that is suspended, or that is held up by pillars below and a wire or a rod above, and these happen periodically throughout this the length of this walkway to keep it up, keep it supported. The wire or the rod above the this cable above the platform has a diameter of 1.27 centimeters. It's made out of steel. The columns below have a, this cable here has a length of 5.75 meters. The column below are circular cylinders, so hollow, with an inner diameter of 16.16 centimeters and an outer diameter of 16, so an inner diameter of 16.14 centimeters and an outer diameter of 16.24 centimeters. And they are 3.25 meters tall, and they're made from aluminum, which has a Young's modulus of about 70 gigapascals. So we can figure out the cross-sectional area of these two things, given the diameter and given the inner and outer diameter of the hollow cylinders. And so the cross-sectional area of the cable is here, and the cross-sectional area of the columns is this value. And now what we can do is we're told that we have a certain load here that is 8.5 kilonewtons, basically acting on one of these, this column, this pair here. So what we can do is we can just basically say, okay, this thing is a spring and this thing is a spring. And so we just model it with two springs with a load acting where they're connected, and we're looking for the displacement. And so the stiffness of a wire or a rod in compression is its Young's modulus times its cross-sectional area divided by its length. So we have all of these things for both the wire or the cable and the columns underneath. And so we can figure out that the stiffness of the cable is 4.41 times 10 to the 6th Newton per meter, and the stiffness for the column is 5.84 times 10 to the 6th Newton per meter. And then basically these two springs act in parallel, because they both act to counteract this force here. And so our displacement is F times the equivalent spring constant, which is the sum of the two spring constants, and we get that the displacement is 860 micrometers, or about 0.86 millimeters.